Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks for Geeks problem of the day, and today's problem is subarray with zero sum, and it is a medium rule problem. So this problem is actually a part of a very standard problem that you must know, and we also encountered one problem, I don't remember the day exactly, but it was not so long ago, in which this problem was used as a base, and then we did something additions on our own, right? So it's very important, this video is very important because this will be used at many places, so please watch it very carefully. So it says that we have been given an array of any teachers, and if there is a subarray of size at least 1 with some 0, you need to return true or false depending on whether the array has a subarray with 0 sum or not. So basically we have been given an array of n size, and we have to tell whether there exists a subarray in this particular array which has a total sum equals to 0, right? So for example, they have also stated here, if you see this particular array, if you take the values 2, minus 3 and 1, if you choose the middle subarray, then the whole sum will be equals to 0, right? This is what they actually want to say. Now how do we actually solve this problem? The idea is not very difficult. You'll be able to understand it very easily. So let's say I have this 4, then 2 minus 3, and then 1 and 6. Now let me calculate the prefix sums of this particular array. So this is my prefix sums, and these are going to be 4, and then 5 6, and then 6 minus 3 is 3, 3 minus 3 plus 1 is 4, 4 plus 6 is 10, right? Now you see that the prefix value, the value of the prefix sum is same at this particular position and this particular position, right? So that is at index 0 and at index 1, 2 and 3. So the value of prefix sum is exactly the same at index 0 and index 3. Do you know what this thing signifies? If the prefix sum is 0, what is prefix sums? Prefix sums is the sum of all the values till this particular index. If the prefix sum has not changed between these two positions, that clearly means that the sum of the values between these two positions is 0, right? Now how do we actually find those elements? So this element will not be included because the elements after it, whatever their values was, their sum is 0, right? So all the elements from here to here, these will be the actual subarray, though we don't need to find the actual subarray right now. I'm just telling you this as a thing, right? So whenever you see that you have encountered the same value of prefix sum before, you already know that you have encountered a situation where the summation of all the values between these two values is going to be 0, right? So this is how you can get an idea of it. Now there are also certain problems where you have to find whether the sum is k, if there exists an subarray where the sum is k. So how do we actually solve it? Now let's say there was a value x, prefix sum is x here, and I want the sum of this particular subarray to be starting from the next position to be k, right? So I want this sum to be k. So what will be the value at this particular position? If the prefix sum is x here, the sum of all the values starting from here to here is equals to k, then the value here should be x plus k, right? So whenever you want to find whether there exists a subarray of sum k, then what you would do? You would take the current prefix sum minus k. You would search for this particular term. Just like we are searching for the current term, that is 4 minus k, that is 4 minus 0 in this case, right? In a general case, you would be searching 4 minus k, right? So this is something that you should know, and this is just a slight modification of the original algorithm that we just discussed. So if you want to find a subarray of sum k, you would look for sum minus k, that is the current prefix sum minus k. In this case, k is equals to 0, so we are looking for the exact same value. So I hope that you guys were able to get an idea of why this problem works, because we can clearly see that if the two prefix sum values are exactly the same, that means all the values that are present in between them has a total sum equals to 0. So this is exactly what we had to do here, and we can maintain an unordered map or a simple map. It's up to you, doesn't really matter. A normal problem would work, but this would have an average case complexity of over 1, right? That's the only thing that we have. Now initially I mark my found of 0 as 1. So why found of 0 as 1? You see that when I have not even taken any element, the prefix sum will be considered as 0, right? So this is a very common and understood thing, that if I have not taken any element, then my prefix sum is 0. So my prefix sum of 0 will always be visited, right? This thing is for sure. Now I initialize my sum value with 0. So this sum is going to store the prefix sum. Now I'm just traversing through all the values and adding the current value to my sum. So you see at each stage my sum variable is going to store the prefix sum till the index I. Now if I've already encountered the same prefix sum somewhere, right? If found.count sum, right? So this is one way of checking whether the element is present in the map or not. Another way is to use found.find, map.find. That is also a great way, but this can also be used, right? Now if it is already present, I can just return 1, otherwise I can just insert it into the map, right? And at the end I can return 0, because if this return 1 was not triggered, that means the sum of 0 is not present in my subarray. So right, so at the end you can return 0, and this was it for this particular solution. Let me just quickly submit this and show you that this particular code works. So you see it passes all the test cases, and this solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and that you're able to reach much more people like you who want to keep solving new problems. So again, this problem is a very standard and interesting problem, and it is used as a base problem for many other hard problems as well, right? So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.